Hey everyone, my name is Sahil, and in this video we will understand why every rooftop solar plant needs a lightning protection system. We will discuss various components of a lightning protection system which are necessary for protecting your rooftop solar plant, including lightning protection design. Number 2, specific issues faced by solar plants during design and installation. Thirdly, the external protection such as lightning arrestors and down conductors. And number 4, the internal lightning protection system for a structure. Please note that the construction of a rooftop solar project does not increase the risk of lightning. This is a myth. So let's start by understanding lightning protection design. Accurate design is important for solar plants as they're placed on the top of a building and it makes them vulnerable to direct lightning strikes. The design of the lightning protection system can be done in 3 ways. Firstly, the rolling sphere method. Secondly, the protective angle method. And thirdly, the mesh method. You can understand all these design methods in detail by reading our blog. The link is in the description. Different methods of lightning protection design are used depending on the specific requirements of a rooftop solar project. However, amongst the 3 lightning protection design methods that we discussed, the protective angle method is the most popular for rooftop solar protection. The protective angle method is a 3D concept as shown in this figure. The protected area is the cone that is swept by the line that emerges from the tip of the air termination rod and ends at the surface of the structure. The protected area will be cone shaped in the case of a simple air termination rod, but it can also be tent shaped in case of a catenary wire as shown in this figure. The angle of this cone is determined by the class of lightning protection chosen during the risk assessment phase of lightning protection design. The lightning protection system design that we get at the end of using the protective angle method or the rolling sphere method or the mesh method will provide information to the system installer, such as the location of the lightning arrestors, the location of the down conductors, the earth electrodes, any other equipment, and the complete bill of material needed for lightning protection. Lightning protection system design requires many measurements, calculation, and years of experience to execute perfectly. With more than 25 years of expertise, Axis offers the entire process from system design to product supply and even installation with internationally tested products. Now let's get back to the subject at hand and let's talk a little bit more in detail about the 3 parts of the external lightning protection system. Firstly, the air termination system. Secondly, the down conductor system. And thirdly, the earth termination system. First, the air termination. A variety of air termination systems can be used in conjunction with the rooftop solar plant depending on the dimensions and the materials needed in that space. These systems include the Franklin rods or conventional system, the early streamer emission or ESC lightning arrestors, the catenary wire system, or any other options. The person designing the air termination for a rooftop solar plant should take extra precautions in this case because these rooftop solar plants face very specific issues during installation. The first is space optimization. One of the main goals of rooftop solar plants is to fully utilize the space that is available, which is usually quite limited. There needs to be good coordination between the technicians like designers, installers, and the rooftop solar system to make sure that the space is adequately optimized and is meeting the requirements such as separation distance. Secondly, solar tracking. Modern solar farms include tracking, which makes the PV modules move along with the movement of the sun. The designer needs to be aware of this movement and make sure that the modules are protected throughout the day regardless of their position. Thirdly, shadows. The efficiency of a solar plant can be affected if the lightning protection system, especially the lightning arrestors, cast a shadow on the modules. Thus, the designer should make sure that they minimize the impact of shadows on the PV system. Fourthly, separation distance. The separation distance between the modules and the lightning protection system is vital. There is a minimum distance required as per the installation standards to make sure that uncontrolled flashovers to adjacent metal structures such as PV modules or frames do not occur during a lightning strike. If separation distance is not maintained, it could lead to a fire in the system. Fifthly, the fall of the lightning arrestors. If the long metallic lightning rods or ESC lightning arrestors are not designed or installed correctly, they can fall on the modules and cause significant financial losses. Therefore, one should only rely on trusted technicians and tested equipment when designing and installing the lightning protection system for your rooftop solar plant. Now, let's discuss the down conductor system, which is the second part of external lightning protection. Down conductors are connected to the lightning arrestors and then taken to the ground to provide earthing for the entire system. Special care needs to be taken to maintain a minimum separation of the down conductors from the solar panels and other metallic surfaces. They should only be installed away from doors, windows, or balconies, or any other point where they might be within human reach during stormy conditions. Finally, the earth termination system. The exact design of this earth termination system will depend on a variety of factors such as soil conditions, local regulations, and the space available. Make sure that you talk to an experienced designer when designing your earth termination system. Now we're done with the external lightning protection, and let's talk about the internal lightning protection system. While the external lighting protection system helps protect the rooftop solar plant and the building from direct lightning strikes, the internal lighting protection system can be as important because you need to protect the internal systems of the building from indirect effects of nearby lightning strikes. For example, lightning striking a power line that is entering the building can cause a power surge that affects all the electrical systems connected to the power line, including your rooftop solar plant. The internal lighting protection system uses equipotential bonding and surge protection devices to ensure protection. As an example, equipotential bonding of all metallic surfaces at the border of each lighting protection zone can protect the next lighting protection zone from a potential surge. If you want to learn more about lighting protection zones, you can read our detailed blog on the subject. The link will be in the description. I hope you now have a clear understanding of how to protect your rooftop solar project from lightning strikes. At Axis, we design lightning protection systems and have been manufacturing the entire range of lightning protection components for more than 25 years, with supplies to hundreds of projects across more than 80 countries. Please share your feedback and queries in the comment section below. Do like and subscribe to our channel for more videos about electrical engineering, earthing, and lightning protection. I'll see you in the next video.